Hi everyone, so I'm going to show you guys how to do basic simulation data that you will need later on for all of your assignments. So me and my friend Elaasma are going to divide the task among us. So basically in the Reservoir Simulation there's 8 main sections, which is I'll guide you through it while I'm doing it. So the first section in simulation is run spec. Underneath it, you're going to include your title, which is UCSI, and then you have your fluid properties, which is oil, gas, water, and this gas. This gas is because my reservoir is undersaturated. It's below the bubble point pressure. And then you're going to include your dimensions, which is your well dimensions, 52 columns, 36 rows, and 13 layers. And then your well dimensions, which is you have 11 wells and 13 layers, and 2 aquifers and 11 wells. And then your start date, and then your rig dims, which is 13 layers and 4 regions. And then your aquadims, we have 2 aquifers, 667, 676, and 468. So the reason that we got those two numbers because we have the east direction, x times z, the south direction, y times z, and we take the bigger value and input it down. So my 4-star is actually for default. For LGR, and then you have the 3 commands that the question asked you to state, which is unif in, unif out, and your field. And then you have your tab dims. So the second most important element is the grid. So your grid, the question asks you to include your USCSI grid cell. And then there are 2 methods actually, block and box. In this method, we use the block method. So we have an important keyword over here, which is carfin. It's used for my LGR. You list down the values that was given in the question and the answers that we got previously.
Hi, so I'm Elaasma and I'll be continuing the second part of the question.
Carrying on with the prop section, there will be 2 includes file. One of the includes file will be for the PVT information, and the second one is for the saturation information. For us to change the SWL and the SWCR in layer 7 as required in the question, we use the box method, and we'll multiply these values with the rows and columns together, which gives us 1872. For the density, we would be using the keyword density and adding those values given in the question, while for PVTW, we would be including the water formation volume factor, and at the certain pressure that has been given, as well as adding the rock properties under the keyword rock and the values that has already been provided. Next section is the Reagent Section, and we will be including an include file known as the FIPNum grid cell. For this part, we would be using the keyword includes while we will be inputting the fit players required. We would be having 13 fit players based on the amount of layers that we will be having, and we would only be changing the values of the fit player in the Z part, which is shown in the video. Solution section would be the next section. We would be using the keyword equal with an I, and we'll be including the depth and the pressure at that depth, as well as the gas water contact, and the rest will be defaulted as following from the reference manual. We also include the keyword RTT-solve for us to have a report for solution. As required in the question, we need 2 restarts and the FIP player and FIP of 3, and hence we included these. The aquifer used here is the Fitkovish aquifer, and hence we use the keyword aquafitp. The depth of this aquifer is located at 8,500, and the total compressibility is 1 times 10 to the power of 6, as well as the water rate of 7 mmSTB and the supply rate of 4 BBO per day. Con keyword is used for the location of the aquifer, so it is located in the I plus region, which is the eastern, and for the J plus it is located in the southern part.
So for this section, we're going to show you how to drill an injector or a producer, or convert a producer to an injector. So this is all done in my schedule section, which is the 7th element in my simulator. And so there are important keywords in my schedule that you need to include. We have RPT sketch and RPT start, RPT RST. So the RPT sketch, you include your FIP and your number of wells and your CPU and your Newton. Afterwards, we're going to start into the how to drill a producer. The first keyword you're going to include is well spec. So you have the number of producer, which is the producer that you're going to drill. That's extra. We have producer 5, which direction we specified the west. It can be any direction. And then you have your dimensions where the well is exactly going to be drilled. And you have what kind of producer, which is oil producer. And then you have your ComDat, where you're going to list if it's open or shut, or what's the status of it. And you're also going to list your skin factor there.
To drill an injector, you have to allocate a specific coordinates for the injectors that you would like, and hence we would be using well specs as for us to locate that. So as we locate the coordinates, we would place them after the whether you're injecting it from the west or the center, and we would put in the coordinates. Anything else would be defaulted by the use of the reference manual. Next will be the ComDat, where you would be specifying whether it is an open or a shut injector. We would also include the wellbore diameter and the skin factor of these injectors. For the well control injection, and then that is where we specify it by the keyword that has been written. This is where to state whether it is also an open rate or an open or shut, and also state the rate of the injected fluid, whether it's water, oil, or in our case it is water, as well as the maximum capacity that it could be injected in. Also, carrying on with the how to convert producer to injector, we would also need to specify our producer, and we would have to shut it first, and then after that refer to the manual for the defaulted areas, and also specify the BHP, and in our case it's 250, also the maximum capacity that is required for it. And then we would be changing it to an injector by identifying the location of it using well specs. And then we will also still continue using the keyword ComDat for us to specify the wellbore diameter and the skin factor of the injected well. Summary section is the last section of this in the data file. We would use the include file of summary, and the main keyword here is performa. It is the most essential in this section, and we can also have an output of more than one thing, which is, for example, the well oil production rate, the well BHP rate, the well water production rate. Everything will be supplied by the reports in the summary section.
So you just click on the open and click on your desired data file that you would like to run. So let's say this is the example. Okay, so I have it ready open over here. Here is my data file. So if I click on the maps, it's going to show me where all my producers are located and my injectors as well. If I click on the graphs, it's going to show you your oil rate, your water rate, and if you click on the FIP num, FIP player, your wells. So this is where you get all of the information.